Please let go.
And I did that, and it gave me, it said, you trying to sweat.
Yeah, and then I touch the third finger and it'll go.
Yeah.
If you do that enough times, it'll be like, you know,
Yeah.
you go back.
Yeah, so it did that to me during the exam.
If you go to modules, did you find it?
I got this, I only got it open for about 20 minutes. I think.
And it's by student ID. At least knew to do that. If you go to semester exam, modules, CCP grades, it should say fourth period. If you want to write your information down, you can. But this is basically what I have at this point. For you or for everybody in here. So you got the chapter tests, you got the quizzes, you got the homework. Now on the homework, what I did at this point was I just took your homework grade to this point. And I usually drop the lowest homework. So if anything, it could go up slightly. Okay, unless you don't turn in the semester review. Okay, so that's not, I mean, this isn't exactly where it's at right now, but it's pretty close. Now remember, so you basically take 50% of your test average plus 12.5% of your quiz average plus 12.5% of your homework average, and that'll give you the final average at this point. To figure out what your grade is, you add in 25% times your semester exam. So right now, your final average is what you would get if you got a 0 on the exam. So if you just chose to come in here and draw bunnies on your test and get a 0, that's what you're gonna get. So pretty good, everybody passed. Now, if you download this, I think you can download that. How do you do that? Download. You can type in a grade for your exam, and you can get an idea what you need to get to either maintain or to get higher. So if I just pick right here, and I type in 85, and if I hit enter, it goes to 93.44. So at least you know. So if you want to get the bare minimum to get the 90A, so you can keep figuring out. So 75, enter. So it'd be a 90.94. Can we go down to a 74? 90.69. We'll go down to a 70. Whoops, a 7 would not work. So if you get a 70, you'd have to, you're 89.69. Sorry, B. Better get a 71 on that one. So if you want to figure out what you need, you can do that. To figure out, like I said, if you to maintain a grade, or if you're like on a borderline, you want to go up a grade, you can figure that out.
It has to be a 72.
72?
Yeah.
This is not you, is it?
It is.
It is?
Yeah.
You're not supposed to tell anybody.
Well, that's me.
All right, if you get a 72. You get a 71, you're getting a B. Let's just let you know that right now. So, Mackenzie. Welcome. So if you download now, I got this available for about the first 20 minutes of class. So if you like want to write down your grade, what you got, you can do that. Just kind of have an idea what's going on.
We got something to do. Which is.
Wait, okay, so
Yeah, I can get a 70 on that.
But that's what you do when you're in college. You say, all right, I gotta figure out, I need an 85 on this test, or I need a 90 on that test, or I need 100. I don't think so. All right, any questions? Any questions? Okay.
That's what I got there.
All right, 20B. Then I gotta go over a couple other things. This was from, similar to the last test, there's just too many mistakes. That were made on this one. When you have, all right, we're dealing with logs, so we want to condense. If it's a plus, what do we have to do to condense? You multiply. If it's a minus, what do we do? Divide. So I can't give you problems of everyone. So if it's a minus, you still need to be able to know how to do that. You divide. So it's log base 5 of 3x plus 7 times x minus 2 equals 2. Okay. Now I had too many people do this. They just don't write this down. They said, don't do that to me. They just said 3x plus 7 times x minus 2 equals 2. They just wiped that log base 5 away. Can't do that. That's wrong. What do you have to do? Okay, from that original one. That's right.
You would do 5 squared equals 3x plus 7, x minus 2.
Yep, you gotta take 5 as your base. 5 is your base to the second power equals 3x plus 7 times x minus 2. Okay, so you can't just drop. The only time you can drop the logs is if you have a log equal a log. You have the logs on both sides. You have a single term on each side. So maybe there's a little bit of confusion there, but this one you gotta write is 5 squared equals 3x plus 7 times x minus 2. 25 equals 3x squared minus 6x plus 7x. Did I write that down right?
Yeah, it's supposed to be a 5.
Why did I put a 2? Makes no sense. So that's supposed to be a 5, and that's supposed to be a 5. There we go. So that gives me minus 15x plus 7x is minus 8x minus 35. Set it equal to 0. So I get 0 equals 3x squared minus 8x. If I subtract 25, I get minus 60. Okay, that will factor. Go ahead and work on your factoring skills. Spelling. For that one. You went the soft route. All right, 10 times 6 gives you 60. Okay, and so if I put, I think it is plus 10 minus 6, that'll work. 3x plus 10 times x minus 6 gives me negative 18x plus 10x gives me negative 8x. So 3x plus 10 equals 0, which x equals negative 10 thirds. And then x minus 6 equals 0, which gives me x equals 6. Don't forget for logs, you have to test the answers, not just to see if they're right, but to see if you get an extraneous solution you gotta throw out. So remember, we cannot take the log of a negative number or zero, so plug those back up into the original. Do either of those give us a negative number? Or are we just sitting in silence? Serenity.
Negative 10 thirds doesn't work.
Negative 10 thirds does not work because you plug it into x minus 5. Negative 10 thirds minus 5 is clearly negative. Okay, 6 will work. Now, don't assume just because a number is negative it doesn't work, and don't assume just because a number is positive it does work. Because if we got back 4, the number 4 wouldn't work because 4 minus 5 would be a negative 1. So just be careful on that one. All right, so that was 20B. I wanted to hit that one just because too many people have been missing it in different cases. All right, here's just some other problems we're going to go through. Not they're mirror ones on your review, but I don't think they're exactly the same. This one. All right, from the last test, oh no, not the conics test, the test before, chapter 4, 3 times 2 to the x plus 1 equals 5 to the x minus 3. Dividing by 3 doesn't really help us a whole lot because you got this power here. It's probably going to, well, there's really actually no easy way to do it. I think it's a little bit easier if we take the log right here, where it is a product. So take the log of 3 times 2 to the x plus 1 equals log of 5 to the x minus 3. Now that log, that one on the left-hand side, that's a product. Okay, so that 3 does not like go out in front of there at this point. You basically, I'll have to split it up. It's going to be the log of 3 plus the log of 2 to the x plus 1. And then the one on the right, since it's a single term, I don't need to split it up at that point. All right, now take your exponents. So don't forget those go out in front. The log of 3 is just, that won't get affected. X plus 1 goes out in front of the log of 2. X minus 3 goes out in front of the log of 5. Log of 2 is a constant. That will distribute in here. Log of 5 is a constant. That's not a base. Okay, because when you get the log base 2 of something, you can't distribute that. When you just have the log of 2, that can be distributed. So now I got log of 3 plus x times log of 2 plus log of 2 equals x log of 5 minus 3 log of 5. I get every term with an x on one side, get every term without an x on the other. I'll do that here in a second. So I'm going to, what do I want to do? I'm going to add the 3 log of 5. I'm just going to put it over here. I'm going to subtract x log of 2. Okay, and then that gives me log of 3, and I'm going to do log of 2 plus 3 log of 5 equals x log of 5 minus x log of 2. Factor out your x. So that's going to stay the same. Log of 3 plus log of 2 plus 3 log of 5 equals X. Log of 5 minus log of 2. All right, once you divide by that, just use your calculator. I know on your paper it says the exact value. Don't worry about the exact value. We're not going to do that. That won't be on the exam. But go ahead and use your calculator. Round it to 3 decimal places if you would. When we're done. Ryan, what'd you get?
7.225.
7.225. That sounds right. Okay. Just watch plugging that in. Make sure you get 7.225.
Yes.
All right, put it out. All right, horizontal and vertical asymptotes. This is chapter 3 stuff. Kind of the end of the chapter. If I just give you the equation, you don't have to graph it. You just have to list them. All right, take a look at that first one. So think about what the vertical asymptotes would be and what the horizontal asymptotes would be. All right, vertical asymptotes. Tyler, do you remember how to find those?
No.
No? All right, good. We can tell you. Vertical asymptotes are where the denominator equals 0. Okay, that's where that case is. Wherever the denominator equals 0. So vertical asymptotes, denominator equals 0. So that's just going to be x minus 2 equals 0. 2x plus 3 equals 0. So they're going to be at x equals positive 2, and that's going to be x equals negative 3/2. Make sure you list them as a equation, like x equals. Don't just put 2. You got to put x equals. All right, so those are you get 2 of them. 2 of them. Cole DeLuca, do you remember how to get horizontal asymptotes?
The numerator equals
No, those are x-intercepts. Oh, Josh thinks he knows.
You plug in 0 for x.
No. Serenity.
It has to do with the powers of like, so like for this one, for a, x squared, and then the top one is x, so that kind of depends on, I don't know exactly how to describe it, but like if they're both x squared, then y equals like a over b.
Got it. All right. It has to do with the degree of the numerator or the power of the numerator compared to the power of the denominator. What's the degree of this numerator? 1. What's the degree of the denominator? 2. If the degree of the numerator is less than the degree of the denominator, then it's always something. It is always y equals 0. So this one here, if this degree is less than this degree, our horizontal asymptote. Hey, put that. Is y equals 0. And that occurs when the degree of the numerator is less than the degree of the denominator. Where the numerator equals 0, those are your x-intercepts. Yeah, those are your x-intercepts. All right, so vertical asymptotes, denominator equals 0. Horizontal asymptotes, where y equal is where you take a look at compare the degree of the numerator versus the degree of the denominator. If the degrees are equal, then we have to look at the leading coefficients, okay, which we didn't need to in this case. All right, look at that second one or copy that second one down. Now, if you look, the numerator does factor, but we don't really need to worry about it for this question. Vertical asymptotes, same thing as before. X equals, I'm just gonna say positive 2/3 and X equals -4, where both of those equal 0. So we'll be fine. All right, now what's the horizontal asymptote gonna be? Since the degrees are the same, you look at the leading coefficient. What's the leading coefficient in the numerator? It's this 9. What's the leading coefficient in the denominator? Cooper, what would that be? 3. So your horizontal asymptote is going to be y equals 9/3, which obviously reduces to 3. That's how you would list it. Vertical asymptote's always x equals. Horizontal is always y equals. All right, we're good? All right. Name that graph. You got one on your review similar to that. This is a rational function because you got a vertical asymptote. We want to be able to come up with the equation of the graph based upon what we can see here. It hits at, that's a 3 right there. This is a -3 at the y-intercept. This is x equals -2. That's y equals 2 for the horizontal asymptote. All right, take a second. See if you can list anything you know. All right, your denominator determines the vertical asymptote, so your vertical asymptotes determine the denominator. So that's going to be x plus 2. Where your x-intercepts are will determine the numerator. So it hits at +3, so that gives us a factor of x minus 3. Because think about this. If you plug in 3, 3 minus 3 is 0. 0/5 is 0. Okay? So x-intercepts determine the numerator. Now, I'm not done. And then this is your vertical asymptotes. For that. What's missing? Or what would be incorrect about this? Yes, either way you want to look at it. Make more?
It needs the 2 on top for the horizontal asymptote.
Horizontal asymptote is 2. That means the leading coefficient has to be 2/1. Right now, the leading coefficient would be 1/1. So if you move this horizontal asymptote down to 1, we'd be good. But it's at 2. So all you got to do is when you have to add a constant, I think it's easiest just to put it right in front. If you want to distribute, that's okay, but you cannot make it. This would be incorrect. If you did this, that would be incorrect. We talked about that earlier in the year because what that does is you just change your x-intercept. Okay, you got the 2, but now your x-intercept should be different. So if you want to leave it like that, that's fine. If you want to distribute it, either way. But that hits everything. That hits everything. Okay, so now you got horizontal and vertical asymptotes. Drawing the inverse given a graph. Okay. So look at that. You don't know the equation. You just have the original graph. And we got to come up with the, just sketch the inverse on the same coordinate system. How'd you do that? Okay, Tyler.
You flip the y and the x.
Yep, if you flip the y and the x. So for any point f on the graph, f of x, if xy is on it, then on the inverse, yx is on it. So you just need to find some points. So negative or 0, -3. That would be -3, 0. Okay, which would be right here. And then I got 1, 2. 1, -2 would be -2, 1. 2, 0 would be 0, 2. That's 3, 4 would be 4, 3. If you have a horizontal asymptote on the original, then you're gonna have what type of asymptote on the inverse? It'd be vertical. So it's going to, and then you can pick a point in here and get close. So that's -2 and like 3 3/4, -3 3/4. So -3 3/4, -2. So it's gonna look like this. And it's gonna go down. It's also a reflection across which line? Y equals x. Okay, if I draw a dotted line through the origin, where's it at? Here. Okay, it's also a reflection across that line. And I know we just did this, but I just want to make sure we're good. I just wanted to throw this one up here. Graph the center, vertices, foci of the ellipse. Main thing, or one of the main things you need to remember, a squared, b squared, and c squared. What's the relationship for the ellipse? Okay, for a squared, b squared, and c squared. Okay,
C squared equals a squared minus b squared.
yes, c squared equals a squared minus b squared. For that, you will not have hyperbolas on it. Okay, so you don't need to worry about this. Just parabolas and just ellipses. And I think on the review you have a parabola. Okay, so at least want to hit one of each. Center, what is that? -3, 1. Center's at -3, 1. Now don't forget, whatever's underneath the x is whatever's the bigger one is always a squared. So a squared is 16, b squared is 9. Whatever's underneath the x tells you how far to move left or right. The square root, which would be 4. I go right, 4. B squared is 9, so b is 3. So I go up 3. I go down 3. And there's my ellipse. Vertices. What do I get for those? -7, 1. You only get 2 vertices. A few of you put all 4. Technically, they're only on the main axis. -7, 1 and 1, 1, which would be right here and here. Your foci got to have the c value. It has to be on the inside. C squared equals a squared minus b squared, which is 16 minus 9. C squared equals 7. C equals the square root of 7. What's that? 2.6. So about 2.6 to the left. 1, 2. 2.6 to the right. And so my foci will be -3 minus square root of 7, 1. -3, plus square root of 7, 1. Okay. All right, you got